Hello, welcome to this lesson in Algebra 1. We're going to be solving equations that have fractional coefficients. All this means is, in our equations, the number in front of the variable is called a coefficient. In these equations, we'll have fractions in front, so we'll have to do a little bit of work. Let's just take a quick example and show you what we're dealing with here. Let's say we have the equation w over 3 plus w over 4 is equal to 7/4. Now this is an equation like any other kind of equation. The goal is to get w by itself on one side of the equal sign, and everything on the other side is what w is equal to. But it's a little more complicated because here we have w thirds, or w divided by 3, and w divided by 4. So in order to add them, it's difficult because these fractions do not have a common denominator. So we can't really combine these w's together easily. So there's two ways to tackle this problem. I'm going to show you the first way, and then I'm going to show you the second way. So the first way is we want to combine them, and we have 3 and 4. What do you think a good common denominator would be? You should have been doing enough fractions by now to realize you can do any common denominator that you want, but 12 is going to work well because 3 times 4 is 12 and 4 times 3 is 12. So that's something easy. So in order to make any progress, what we're going to do is we're going to take the first guy, w divided by 3, and we'll take the second guy, w divided by 4. And what we will do is we'll take the first fraction, we'll multiply by 4 over 4. And we'll take the second fraction, multiply by 3 over 3. Now you see what's happening. We'll now have a denominator of 12 for both of them. So on the left, we'll have 4w over 12 plus 3w over 12 is equal to 7/4. The reason we did that is because we want to combine them. So how do we add these together? Well, the new denominator of that fraction will be 12. And then it'll be 4w plus 3w on the top. I could add them, but I'll just go ahead and write it out. 4w plus 3w on the top, and that's going to equal 7/4. So on the left, 4 plus 3 is 7, so it's 7w over 12 is 7/4. So you see, we did all of that work just to get down to the point where we had 7w is equal, or divided by 12, getting a single fraction on the left-hand side, because then now we want to get w by himself. So how do we isolate w? Well, there's a couple of different things you can do. The first thing we're going to get rid of is that denominator. That 12 is not good for us. So what we're going to have is 7w divided by 12 equals 7/4. And we'll multiply the left by 12. And in order to do that equally to the equation, we have to multiply left and right-hand side by the same thing. So you see on the top up here, we have 12 on the top and on the bottom, so what we can do is cancel these 12s. That's why we multiplied with them to begin with. On the right-hand side, what we can do is we see that we have a 12 on the top and a 4 on the bottom. We can divide top and bottom by 4. 4 divided by 4 is 1. 12 divided by 4 is 3. So let's continue over here and say on the left-hand side, what we have left is just 7w. And on the right-hand side, all we have left is 7 times 3, which is 21. So you see, after we canceled and got rid of all the denominators, we have something nice and easy. We can divide the left by 7 and also the right by 7. So we will have w is equal to, because these 7s will cancel, 21 divided by 7 is 3. So the answer is a single number. W is equal to 3. So I know it was a little bit of work, but you see it's this exact same process that we have done time and time and time again. We ultimately want to combine the w's together and get them by themselves. It just so happens that since we have different denominators, we have to get a common denominator first. So we manipulate